Hello, everyone. Okay, so today we are going to be talking about combining like terms. So let's talk about a term first. A term is a number, a variable, or a product of a number and variable. So one of the best parts about the videos is I'm left-handed, so I always block it out. And then you have to, then you can pause it and follow what I say. But in class, it makes it a little tricky. So let's, in this little expression here, remember an expression doesn't have an equal sign. So we're going to say 6x plus 4 over 5 plus 10 plus 4xy plus x squared. All of these that I'm about to box right here, the 6x, the 4/5, the 10, the 4xy, and the x squared, those are all terms. They're all different kinds of terms. You wouldn't be able to combine any of those, right? Because none of them are the same. But those are all terms. Okay, so that's a term. Let's talk about a coefficient. All right, a coefficient is the number being multiplied by the variables. The number being multiplied by the variables. So right here, if we were to have 5x squared, that is your coefficient. Forgive me, I spell that word wrong a lot. All right, and another way to think about it is the number in front of your variable, coefficient. Okie doke. Next one. So we've done term, we've done coefficient, and now we're going to talk about like terms. So like terms. Terms that have, dun 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 dun, drum roll, I know I'm cheesy. Terms that have the exact same variables, and variables that are raised to the exact same exponent. Sorry guys, this video might be a little bit longer because I have to handwrite everything. So we have a term, we have coefficients, and we have like terms. All right, so now we're going to talk about constants. Constants, not like your Aunt Constance, but constants. Constants, they are like terms. They are always like terms. Constants are always like terms. So a constant a number without a variable next to it. So that stands for a number without a variable next to it. So they are always like term. An example of constants would be the number 8 and the number 2. Yes, they're different because there's no variable about them next to them. You can still add them, just like you add any numbers, 5 plus 7. So 8 and 2. Coefficients Uh-oh, I hope my pen's not dying. There was a trick to this last year to get it to work. Let me find a different red really quick. Here's all my pens. Pretty exciting stuff, huh? Things you don't get to see because you are not right in front of me right at the moment. So coefficients, they do not have to be the same. Do not have to be the same. All right, so the coefficients do not have to be the same. For example, you could have 5x and 3x. Those coefficients, notice how they're different. They don't have to be the same. You can still combine them because their variables are exactly the same, and your answer would be 8x. Okay, so let's talk about like terms and unlike terms. Okay, so some like terms would be 6x squared and x squared. Different coefficients, right? Different numbers in front. However, all that matters is that these variables right here are the same. Okay, some unlike terms would be 5x squared and 10 to the x. Remember, just because there's not a number up here, it's actually the 1. We don't write it because we don't say, I'm 1 Mrs. Black. You just say, oh, Mrs. Black. You know you're just talking about 1. So the reason these would not be like terms right here is because these are different exponents. The exponents have to be exactly the same. Different exponents. All right, so 8 and 10 would be like terms, right? Because they're constants, and constants, it doesn't matter. Unlike terms would be 6x squared and 4y squared. They're raised to the same exponent, but their variables are different, so different variables. All right, and one more like term would be something like 3xyz and 11xyz. They have 3 variables, right? But they're all raised to the same power, and they're all the same variable, an x and an x, a y and a y, and a z and a z. However, if I were to have 2xy and 2xz, I couldn't do that because right here, the y and the z are the different. They're not exactly the same. They're not matchy-matchy. So different variables. Okay, so I am going to move on to the next page right here. And I just want you guys to know, oops, I turned my page of my notes. Hold on one second. I want you to know that when combining like terms, this is very important. When combining like terms, add and subtract the coefficients, and the variables stay the same. And this pen's dying too. This is not my day for pens right now. Add and subtract the coefficients. And the variables stay the same. Okay, so let's do a couple examples. Let's do some examples. Okay. All right, first one is going to be 5x plus 3x squared minus 2x plus 10x squared minus 6. All right, I'm going to go through and highlight these so that I can identify my like terms. My first one is 5x, so it's just an x, right? I'm going to look for my other term that has just an x, and that would be -2. So I know that those two are like terms. My next one is 3x squared. So I'm going to look and see if there's another x squared, and there is. There's this 10x squared. Oops. So I'm going to combine those two. This -6, this constant, this number that's all by itself, is just going to stay by itself. So if I want to, you can combine those in your head, or if you'd like, you can do 5x minus 2x, and you'll get 3x. And then we'll take this positive 3x squared and this 10x squared, and we will add them together since they're both positive. And I will have 13x squared. So now I just rewrite my equation. I'm going to start with the highest exponent. We'll get more into that later, but that's generally where you want to start, the highest exponent. So 3x squared plus, 13x squared plus 3x minus 6. And that would be your answer. Okay, let's try one more. And then when we review this on Monday or our next class day, I'll give you guys 2 examples I want you to try. So, let's do 5x squared minus 10x plus 14y minus 6x squared minus 3y squared minus 17y plus 5x. All right, so I'm going to start by combining like terms. I'm going to first see that there's a 5x squared, and I'm going to look and see if there's another x squared. Well, there's one right here, so I'm going to do 5x squared and -6x squared. All right, so 5x squared and -6x squared. I'll combine those and get -1x squared, or -x squared. All right, so that's my x squareds. The next one I'm going to do is just my plain old x's. So I see that this is a -10x. I'll highlight that, and I'll look for another just x by itself, which I find right here in the 5x. So I'm going to combine those two, -10x and a positive 5x. I'll combine those and get -5x. And then I'll see that I have a y right here, and I'm going to look and see if I have another just y by itself, which I do. So I'm going to go ahead and highlight this and highlight that one and then write them down here. So a positive 14y and a negative 17y would give me a negative 3y. All right, and then my very last one, which has no common friends, which is totally fine. It's just kind of the lone soldier, is negative 3y squared. So he's just going to hang out because there's no one to combine it with. But what we're going to do is we're going to start with our highest exponent. So negative x squared. Again, I don't need to write that one. And then my second highest exponent, but alphabetically, so x, y, z, right? So minus 3y squared, and then minus 5x, and then minus 3y. And that would be my answer. The two that we're going to go over, if you want to give them a shot. So number 3 is going to be 5x squared minus 8x plus 10 minus 2x squared plus 5 minus 3x. So that will be one that we go over. And then the other one, if you want to give it a shot, the other one will be 6 plus 2 parentheses, dun dun dun, x squared plus 3x cubed minus 10, close my parentheses, plus 3x squared minus 8x cubed. All right, so that's it for today's video, just combining like terms. Go ahead if you want and give these a shot, and we will be going over them when I see you guys next. Bye.